Okay, so this is the last video in the series for National 5. I've done the 19, 18, 17 and 16 paper. Yep, and this is the 15. So the 15 and the 16 seem to be slightly shorter than the 19, 18 and 17. And this is just for 40 marks and it's just an hour. Okay, so it seems to go a bit quicker than the other ones. But yeah, I hope you found these good. And obviously, if you've gone through all of them, you see there's a huge similarity between the papers. So the same the same things do come up over and over again. So yeah, please practice. All right. So taking away fractions. I don't think I've actually seen a takeaway in the last four. It's mainly been adding fractions actually, but it's the same kind of process. Okay, so 6 and a fifth take away 2 and a third. Now the first thing I would think here, let's ignore the fractions. Okay, so say we did 6 minus 2, that's going to give us 4. Okay, so right away I know that that is 4. Okay, and then I'm left with doing 1/5 take away 1/3. Okay, so I'm kind of doing like 4 and then I'm adding on whatever's left. Okay, if you imagine that, if you imagine that we do it separately. Okay, if you imagine that this kind of breaks down to 6 minus 2 plus a fifth minus a third. Okay, that's one way of looking at it to start with. The other way you could look at it is to instantly put it to a top heavy fraction. Okay, so you could kind of almost start off with, what would that be, 31 fifths, take away 7 thirds. Okay, you could almost start off that way if you wanted as well. Okay, so just make it a top heavy fraction to begin with. So 6 times 5 gives us 30 plus the 1. 2 times 3 gives us 6 plus the 1. Okay, so you can start off that way as well. In fact, there's another way of starting it, which is similar to this method I've got here. Okay, but I think this is the best way of doing it. Just do your whole numbers and then do the fraction. So 6 minus 2 is going to give us 4, and then we've just got this fraction here. So what do? When we're adding or taking away fractions, we need to get this common denominator. All right, so right now I've got a fifth minus a third, and that's almost the same as saying, one car one car take away one van. It's not the same, is it? You want this common denominator. So if I said 2/5 take away 1/5, we know that gives us 1/5. Okay, because you can imagine it, couldn't you? Say you've got a pizza. I'll do quarters rather than this, right? If I've got 2 quarters, so I highlighted that's 2 quarters, and I take away 1/4, so I take away this quarter here. What am I left with? Well, I'm left with 1/4. Okay, because it's like for like. Okay, but if you've got different size bits of pizza, it's not really the same, is it? It'd be difficult to say, what have I got left? So I've got a pizza that I'm going to break up into, let's say eighths, right? So say I've got 5/8, so there's 1, 2, 3, 4, 5/8. Take away a quarter, or take away a third. It's difficult to say that, because it's not like for like. So that's why you need to do the common denominator, which we're going to do next. All right. So just remember that when you talk about a common denominator, you can't take them away because they're not the same thing. Okay, so we need a common denominator to make it make sense. So we do our smile and a cross. So a smile means you multiply them. So it's 15, 5 times 3, and then we do the cross. So this times this, and this times this. So 3 times 1 is going to give us 3. 5 times 1 is going to give us 5. Now this is the bit where mistakes can happen. Okay, so we've already dealt with the whole numbers. Okay, so I don't have to make it top heavy. Like I was saying, the other way you could do this is to do this part here and then make it top heavy. That actually makes more sense, because if you do this bit and then try and do smile on across, you end up with some big numbers. You end up with the 15ths, which is fine. But then you're doing 3 times 31s, with 93, take away 35. You could do it that way if you wanted. Okay. So what does that give us then? 60, 55, 58, 15s. Yeah, you could say that. And then you say, well, let's put that back to a normal. You could put it back to a normal number if you wanted, which would be 3 and 13 15ths. You could say that. So that is definitely one way of doing it. Or you could wait to this point where you've got it in the 15ths. So you work out your common factor and then you turn it into a top heavy number. You could do it that way. But I quite like this. Both these methods are fine. Okay, I quite like this method though. I just do the whole numbers and I deal with the fractions. So what I'm going to end up with though here is a 4 plus minus 2/15ths, and that's the bit that people struggle with, okay, because 3 minus 5 is minus 2, so we've got minus 2/15. So if I do 4, take away 2/15, what does that leave me? Well, if you imagine you've got, 4 pizzas, 1, 2, 3, 4 pizzas, and I take away 2/15, so I take away 2/15 of this pizza, okay? Well, I'm still left with 3 pizzas, I've got 1, 2, 3 pizzas, and what's left on this pizza? Well, if I've taken away 2/15, I'm going to be left with 3/15 of pizza, aren't I? So I would say I've got 3, write that properly. So I would say I've got 3 and, sorry, 3, 13, uh, and 13/15, okay, because I've taken 2/15 off of this whole, okay. So that's the way I like to think on it. But you would be happy to do this method as well, where you work out, where you put it into a top heavy fraction, do your smile on a cross, and yeah, then I think you could leave it this way, or you could finish it. I think the marking scheme here is giving you a mark for the common denominator, which is that or that, and then it's giving you a mark for leaving it like this or this. So there's two different ways to leave your answer. I think it's always best to leave it as a mixed, to be honest. I think that looks a bit untidy, you know. Um, but yeah, I think this to me is my preferred method of doing it. I think there's less maths involved here. I think when you start getting into the bigger numbers, it's easier to make a little arithmetic error. Whereas here you're only dealing with up to 15. Okay, so yeah, should be a nice easy question to get us started. Bit of fractions, that's always coming up fractions, always, always, always. And smile on a cross is probably the only tricky thing to remember. Don't forget, when you're multiplying your fractions, you multiply the top and the bottom. So if you've got a third multiplied by 2/5, you're going to do 1 times 2 to give you 2, and then you're going to do 3 times 5 to give you 15. So that's the only other rule, which again is a very straightforward rule, which is why they don't always ask us it. And the only other rule is the dividing. So if you've got a third divided by 4/5, we do our KFC. We do keep, flip, change, KFC. Okay, so we keep this one the same. We flip the 4/5. Okay, so we end up with a third, and then 5/4, and we change the sign up here. We change it from a divide to multiply, and then just do the multiply rule. So that'd be 5/12. Okay, keep, flip, change. Okay. So yeah, that's basically your fractions, and every year that comes up. Okay, so 2 marks in the bag, very straightforward. Okay, don't be caught out by that. All right. Solve algebraically the inequality. So question 2. Now, what does it mean when it says algebraically? Well, that means don't just guess x. Don't just sit and go x is 1, x is 2, x is 3, and keep going. So you won't get any marks for that. Okay, so we don't really need to worry about that word anymore. So basically, it's just solve. We can tell it's an inequality as well. So don't get put off by the words in these questions. Okay, solve. So it means what is x? Solve it. Now, an inequality, you can almost imagine that's an equal sign. Okay, there's only one rule, and I'll see if it comes up, that would make it that's not the same as for an equal sign. Okay, but right now, okay, let's just imagine, right? Let's just imagine that is an equal sign. Okay, okay, we just imagine it's an equal sign. I'm not going to do that because that's not right. But just imagine as you're going through the rules. Okay, so if it was an equal sign, if we want to move things over, we do the opposite. Okay, so just imagine it's an equals. Don't get put off. Just think of it as an equals. So the first thing we'll do, we'll multiply that bracket out. Okay, so minus 2. So 2 times 1, and then minus 2 times 3x would be minus 6x, okay, less than 39. Okay, so minus 2 times 1 is minus 2, and minus 2 times 3x is minus 6x. Don't get caught out with your negatives here, okay? Next part, let's put like for like, okay, so 11 minus 2 is obviously 9, and then minus 6x is less than 39. Okay, nice one. Now we want to get x's to one side and numbers to the other side. So let's move our 9 over, shall we? So we've got a plus 9 on this side, okay, because just sat there, plus 9 minus 6x. So if we did like a little working line over here, okay, if we want to move plus 9 over, we do the opposite, so we minus 9, okay, so it turns up over here as a minus 9, okay. So we end up with minus 6x is less than 39 minus 9, okay, which is 30. Now, The working line is one way of doing these things. Again, I've chatted through this in other videos. So the working line is where you write down the opposite of what you're trying to do. So if I was trying to move this over, I'd be doing plus 6x, okay, and it shows you, it just appears on this side of the equation in the opposite form, okay? So if I want to move a times over, I divide. If I wanted to move a square over, I do the square root. And you just kind of keep a wee note here of what you've done. Now what we're actually doing if we want to move something over is we're doing minus 9 to both sides of the equation, okay? So minus 9 plus 9 is going to cancel out here because that gives you 0. And that's why it appears on this side as the opposite sign. Okay, so what you're doing is you're doing the opposite of the plus 9, but you're doing it both sides. And that's why it cancels out on this side and appears on that side as a different sign. Okay, so don't, so if you want to think about it that way, you can. I think that's the way I was kind of taught when I was doing it. But now people seem to be quite happy with just showing this opposite sign in the working line. Okay, nice one. So this is the point I was talking about where this suddenly doesn't now become an equals. Okay, so now what we want to do to get rid of divide by 6, divide by, now to get rid of the minus 6, we need to divide by minus 6, don't we? So I'm going to keep the purple. So if we do divide by minus 6, right, yeah, what's going to happen is the sign's going to flip. Okay, now this is the only thing that is different between our equal sign and inequalities. If we divide by a negative number, the sign flips. Okay, a common mistake actually is to write that, is to leave this the way it was, because the minute I'm doing this divide, it changes the sign. So this is now mathematically correct, okay? But some people write the divide by minus 6 or whatever, and then on the next line they change the sign. Technically, you should do it here, okay? So with the working line, you'd maybe just write, I'll put that back to where we had it. So you now might just write on the working line, well, divide by minus 6, go doing the opposite. And on the next line, that would look like 6 is greater than 30 divided by minus 6. Okay, that's how that would look. Okay, so to get rid of the minus 6 is minus 6 times x. So we need to do divide by minus 6. So it appears on this side as a divide by minus 6. Okay, so on this side it just becomes 1. And the sign changes. It's the only thing you need to remember with inequalities. Divide by a negative, you flip the sign. Okay, now again, if you're not great at that, who cares? You've still got some good marks here for working out the bracket. Okay, so still try something. Okay, and what does that give us? X is then greater than minus 5, isn't it? 30 divided by minus 6 is minus 5. So 30 divided by 6 would be 5. Positive divided by negative gives us a negative. So X is greater than minus 5. Or you could write minus 5 is less than X if you wanted that. No, that's it. The last thing I would say about this question, if I'll just give you the marks first, sorry, just quickly. So you get a mark for multiplying out the bracket, good stuff. And then you get a mark for collecting your like terms. So you get 2 marks for actually just rearranging the equation like this. And then you get your last mark for knowing about the inequality. Okay, so knowing that, for knowing that you would flip the sign. Okay, so 2 marks for just basically imagining it's an equal sign. There's nothing up to there that's any different from just rearranging the equation. But what I would say for this, before my time runs out, check it. Okay, x is greater than minus 5. So when you put minus 5 in, it should balance. Okay, so if we just quickly put in minus 5 to that, I'm going to get 11 minus 2, 1. Now minus 5 would give me minus 15. 1 plus, minus 15. So what does that give me? 1 plus minus 15 is minus 14. So it'll be minus 28 is less than 39. 11 take away 28. Oh, must have made a mistake there. Let me just pause that. Sorry, yep, so it should be minus 2 and minus 14, so it should be plus. So that is going to give me 39 is like less than 39. So obviously, yeah, when you put in that exact number, it basically equals, okay? So that's making me think I've done it right, that's good. So if I put a number higher or lower than minus 5, the inequality should come true. So at that point, when we're saying it's greater than this number, if you put that number in, they should balance out. Okay, so that's a way of checking it. Put the number in below and after to make sure the inequality works. If you put this number in, it should just pop out as 0. Okay, so you can check to make sure you've got the right answer as well. So again, I like these questions where you can see how you're getting on. You can be like, right, does this make sense? Plug it back in. Okay, so 2 marks for just rearranging an equation, 1 mark for an inequality, and then think to yourself, okay, well, does that make sense? I'm going to put in minus 6 and minus 4 and see if this equation actually holds true. Simple, all right? Good.